Hi, I'm Kian, and today I want to show you how to solve some AP Calculus BC multiple choice questions. So I've included 3 questions from the previous exams, and I want to show you how to solve it exactly. So let's dig into the questions. We have if inverse sine of x is equal to natural log of y, we want to find dy dx. So dy dx is the same as the derivative of y with respect to x. So we should actually differentiate both sides. Differentiating inverse sine of x, we get 1 over, and then the square root of 1 minus x squared. And then differentiating a natural log of y with respect to x, we get 1 over y, but we should multiply by dy dx, and this is called the implicit differentiation. So we should multiply it by dy over dx. Now, for solving for dy dx, we should multiply both sides by y. So we get that dy over dx is just y over the square root of 1 minus x squared. We get y over the square root of 1 minus x squared. Okay, this is the answer for the first question. Let's go to the second question. For the second question, we want to find the radius of convergence of this series. So the series from 0 to infinity of x minus 4 to the power of 2n over 3 to the power of 3. 3 to the power of n. 3 to the power of n. So for this, we have to use the ratio test. So first of all, I'm going to evaluate the absolute value of a sub n plus 1 over a sub n, and then take the limit. So we have the absolute value of, and then a sub n plus 1 is x minus 4 to the power of 2n. And then over 3 to the power of n plus 1. And then we should multiply it by 1 over a sub n. So we get 3 to the power of n, and then over x minus 4 to the power of 2n. And sorry, I made a mistake. At the top of the numerator, it should be x minus 4 to the power of 2 times n plus 1, which will be 2n plus 2. I made a small mistake. Sorry for that. So now we can actually simplify this, because we see that x minus 4 to the power of 2n plus 2 can be splitted. X minus 4 to the power of 2n cancels. We're just left off with the absolute value of x minus 4 and then squared. And 3 to the power of n plus 1 is 3 to the power of n times 3. So 3 to the power of n cancels. We are just left with 1/3. So we get x minus 4 squared over 3. And for this series to converge, the absolute value of a sub n plus 1 over a sub n, which is this, should be less than 1. And now solving for it, we should multiply both sides by 3. So we get absolute value of x minus 4, and then squared is less than 3. And then taking the square root of both sides, we get the absolute value of x minus 4 is less than square root of 3. So the radius of convergence is square root of 3. This is r, the radius of convergence. And we're done with this problem. Going to the last problem, we are going to evaluate the definite integral from 0 to 1 of 5x plus 8 over x squared plus 3x plus 2. When I see these types of integral, I just go for partial fraction decomposition. I'm going to use this color. So we can see that we can actually factor the denominator. So I'm going to write this as the integral of a over x plus 1, or x plus 2, doesn't matter, x plus 2, and then plus b over x plus 1. Now I'm going to use a cover-up method. I'm going to set x plus 2 equal to 0. We get negative 2. Now I'm going to evaluate this at negative 2. So negative 2 times 5, we get negative 10. Negative 10 plus 8 is negative 2. And then negative 2 over negative 2 plus 1, we get 2. So a is equal to 2. And then same thing for the second part, x plus 1, set it equal to 0. We get x is equal to negative 1. Evaluate it. Minus 1 plus 2 is 1. And negative 5 times 5 times negative 1 is negative 5, plus 8 is 3. And then 3 over 1 is just 3. So now we can actually integrate and then evaluate this integral. So I'm going to use this color. When integrating this, we just get 2 times natural log of absolute value of x plus 2. And I'm going to actually evaluate this from 0 to 1. This would be equal to, when we put 1, we get, we can actually forget 2 for now. Natural log of 1 plus 2 is natural log of 3, and then natural log of 0 plus 2 is natural log of 2, but we can use a log property that natural log of, for example, n minus natural log of m is natural log of n over m. So this is the same as 2 times natural log of 3 over 2, and we can raise the 2, actually simplify it. So actually I'm going to write it as natural log of 9 over 4. So let me write it as natural log of 9 over 4. And then we should subtract this actually. And actually, sorry, not subtract, we should add it because you're adding 2 different integrals. We should add this to 3 times natural log of absolute value of x plus 1. And then we should also evaluate this from 0 to 1. So when we evaluate it, natural log of 1 plus 1 is natural log of 2, and then natural log of 1 is just 0. So we just get natural log of 2 for our answer. And then when we raise the 3, because we use a log property, and then 2 to the power of 3 is just 8. So for this, we just get, for this integral, we get natural log of 8. Now we should add these two natural logs, natural log of 9 over 4, and then natural log of 8, and then we use another log property. Then when adding 2 different natural logs, we can actually multiply the inside, and the answer is natural log of the product of that. So for our final answer, we just get natural log, and then multiplying 9 over 4 times 8. 8 times 9 is 72. 72 divided by 4 is 18. And we don't need plus c because it's a definite integral. And that's it for this problem.